Welcome to lesson 59, and again we're going to practice some more combining like terms, and this time we'll have a special focus on the distributive property. So watch as I simplify the expressions using that property, and how we identify our like terms versus our non-like terms to simplify it, and use our order of operations to get the entire expression down to one term. We are going to look at a problem with distributive property. Means I'm distributing, I'm giving things out, but we're going to see it with this model. Super cool, really helpful for simplifying expressions. So let's jump into this one. Benito is creating a rectangular garden. So see, I made it right here so you can see his garden. The garden is 3 feet long and 2 plus x feet wide. So I'm going to show this to you. So 3, 2 plus x feet wide. I'm going to put that right there. The expression 3 times 2 plus x represents the area of a garden. Simplify the expression 3 parentheses 2 plus x using the distributive property. So this is what I'm going to tell you, math marbles. When we see an expression like this, there's a parentheses, there's a number outside. This is going to be our key that we're going to distribute. It means we're going to give out. We're going to do something with those numbers. Like when I distribute test papers, when I distribute pencils, I'm giving things out to everyone else. So we're going to see this. What this tells us, this 3 on the outside, is telling us that there are groups. There are 3 groups of 2 plus x. That's what this tells us when I read this expression. So I'm going to look at my little garden for a second, and what I physically see are 3 groups, there we go, of 2 plus x. So inside the garden I have 2 plus x, 2 plus x, 2 plus x. So I have, there you can see it. You can see my 3 groups of 2 plus x. So that's why I like this area model for this. So one way I can write this, I could have repeated addition and say 2 plus x plus 2 plus x plus 2 plus x. I can do this 3 different times. Or I can just put the 3 on the outside and 2 plus x. And that tells me the same thing. It tells me that I have 3 groups of whatever is inside your parentheses. In this case it is 2 plus x. So how do we actually use the distributive property? I'm going to show you right now. So imagine, if you will, I'm just going to have the garden. So looking at the garden for a second, if I wanted to know the total of what I had and combining all those like terms, I can physically see that I have 3 sets of 2, or I can just combine all of those and say, well, I have 6. Right? You can see it in there. And then plus all my x's together. I have 3 x's. So I could simplify all of this down. Instead of saying 3 sets of 2 plus x, I could say, well, I have 3 sets of 2's, which is 6. And I have 3 sets of x, which is 3x. So I can simplify this. So how do we make this true? This is what can happen, math marbles. 3 sets of 2's, which is 6. 3 sets of x, which is 3x. Some people call this the bird beak method. And it's like going and doing this multiplication, saying I have 3 groups of 2. So it's just multiplying by 3 to get 6. And then doing the same thing on the other side, 3 times x to get 3x. And that's all it means to distribute. That's it. Some students just look at it and go, that's it, miss? That's all we got to do? Yeah, that's basically it. It's just figuring out I have 3 sets of the first term and 3 sets of the next term, and then just write it on the bottom, and you've now combined like terms and you've simplified it. So that's what we're going to practice out for today. But let's hit pause so you can jot this one down. I promise you we're going to get more practice, and it will go by so much more quickly. Let's write another expression equivalent to 6 times W minus 3. So again, what do we know? I know that I have 6 groups of this. So I'm going to use my method. We could say this, so you could expand it and do this 6 times, which takes up a lot of time. 1, 2, 3, 4, 5, 6. Or you can look at this and go, I have 6 groups of W. Or in your mind, you're going, what is 6 groups of W? 6W. And I have 6 groups of negative 3. 6 groups of negative 3. That would be negative 18. And that is it. That's all I did, Math Marbles. I just did 6 times W, 6 groups of W, and 6 times negative 3. That's all I physically did in my brain to get this answer, 6W minus 18. If you are still struggling, you could expand and write this out. And once you expand it, you could then just combine the like terms and add it all up. I have 1, 2, 3, 4, 5, 6 W's. And let's add up all my negative 3's. Negative 3, negative 6, negative 9, negative 12, negative 15, negative 18. If you're still in the beginning point where you need to expand, that makes sense, but please make sure that you're practicing this out. This will take longer and longer as we get to more complicated numbers. Or you can use a simplified version right here, which is Distributive. That is actually what we're doing today. Please let your teacher know if you are finding yourself needing to expand out and you want to get some ideas or more practice on how to do it using the distributive property. Hit pause and jot this down. We have one more example to go. Up to the last one, we're going to simplify this expression. We're going to think about what operation is represented in that first term. And is there another way to phrase 3 groups of 6m? Can we model it visually? Okay, so we have 3 groups of 6m plus m. So A, what operation is being represented? Remember, if we see a number in front of the parentheses, it's telling me groupings. 3 6m represents 3 groups of 6m. This can be repeated addition or multiplication. Okay, and we know that the more effective way, more efficient way is probably multiplication. So let's look at B in the second one. Can we represent this in another way? Well, of course we can. We can represent 3 groups of 6m. Let's look at it visually. I could, let's draw an array again. And this tells me I have 3 groups. And in each group, I have 6m. And I could simplify this by combining like terms and just saying I have 18m. So 3 times 6m is equivalent to 18m. Those are 2 other ways I can visually show and represent this problem. So let's do our final count. Let's actually simplify this entire expression. 3 times 6m plus m. I'm going to distribute first. There is nothing to do in terms of the 6m. I can't simplify that further, but it does represent multiplication, so I'm going to do that in my order of operations next. It's my visual. So I have 18m plus m. And because, again, I have like terms, I have a bunch of m's. So I have 18 m's, and I add one more m, I now have 19 m's. And this is in simplest form. So there you go, Math Marbles. We know how to visualize. When we see distributive property, we know what that means. We can say it in words. We can say it with a visual. We can draw it out. We can expand it so we can see what it means. Or we can use distributive property to do it in a nice compressed form and just multiply by an outside term to combine like terms and simplify it into one final term. So we're going to pause there. You're going to get tons more practice. We're using a lot of big words and big ideas, but you definitely got this, Math Marbles. Keep practicing with distributive property to simplify your expressions, and please ask an adult if you have additional questions while you're working on the purposeful practice. I'll see you in the next one, Math Marbles. Take care.